The two problems that we didn't get to in class together for our long division for polynomials were the two that related to dividing by quadratics. And so I wanted to give us a chance to go over these together after asking you to look at them on your own first. So now that you've had time to look at them on your own, let's see how we would go about solving these kinds of polynomial divisions. So we're going to set them up just like we did all of the previous ones, where we'll have our divisor. So we have x squared minus 5 is dividing x cubed plus 5x squared plus 2x and minus 32. And just like before, we're going to set it up to say, first of all, if I have x cubed and I divide it by x squared, what kind of multiple am I going to get? Well, those cancel out to give me x, so I would take just an x here. And x times x squared minus 5 gets us x cubed minus 5x. And remember, we said go ahead and multiply it by a negative so that we can add instead of having to subtract. So that would give us our negative x cubed plus 5x that we can now add. So negative x cubed. Well, plus 5x lands us over here. Notice we don't have an x squared, and that's okay. Let's bring down the 5x squared plus 7x and minus 32. And let's see if we can find a multiple that will work for this one. So this one we have 5x squared, and we're going to divide that one by x squared to see what we can multiply it by, which those x squareds will cancel out. We just get 5. So now we just get plus 5. Well, 5 times x squared minus 5 is 5x squared minus 25. And if we multiply that by a negative, so we can add instead of subtract, we get negative 5x squared plus 25. So do our negative 5x squared, no x this time, and then plus 25. And we are left with 7x, and negative 32 plus 25 gets us a negative 7. And there's no whole term that we can multiply x squared by to get 7x. So at this point, this 7x minus 7 is our remainder. So we would say then that, put it in the right color, x cubed plus 5x squared plus 2x minus 32 divided by x squared minus 5 is the same as x plus 5, right, plus our remainder, which is 7x minus 7 over our x squared minus 5. Now, if we wanted to, we can make that 7 times the quantity x minus 1. And that's just a little extra step that we don't necessarily need to take, but we could. But this is where we would end up as our quotient. Let's try the other example, which, by the way, is not the one that I had written down to do. I made a couple of typos, but we're going to do it the way it's given here. And then we can also look at it if I changed it to the other signs that I meant to have on there. So I also noticed this should have been f of t. So f of t is equal to 3t to the 5th minus t cubed plus 2t squared plus 68t plus 10 divided by t squared minus 5. So let's find another way to write f of t by doing polynomial long division by a quadratic. So we're going to divide t squared minus 5 into 3t to the 5th minus t cubed plus 2t squared plus 68t and plus 10. So we can tell from the beginning, because it's a t squared and then a 5, which has no t's, that each time we do our multiplication and subtraction, we're only going to have a difference of 2 degrees in our terms. So you're not going to get, a subtraction that's going to have a fifth and a fourth, or a fourth and a third, or a third and a second. It's going to be a fifth and a third, or a fourth and a second, those kinds of subtractions. So let's see how that pans out. Let's start with our first one, which says I have a 3t to the fifth, and I need to divide it by my t squared. So we end up with 3t cubed. So our first part of our quotient is 3t cubed. So let's do our 3t cubed times our t squared minus 5. And we end up with 3t to the fifth, which we should have. And then 3t cubed times minus 5 is minus 15, because it's just 3 times negative 5. So minus 15t cubed. If we multiply by a negative so that we can add instead of subtract, we get negative 3t to the fifth plus 15t cubed. And this is what I was saying earlier, was that you're going to see a difference of 2 in the degrees of these terms. So 3t to the fifth has a degree of 5, but 15t cubed only has a degree of 3. So when we bring these over, we'll have our negative 3t to the fifth. And luckily in this problem, I didn't give you any t to the fourths. So we're okay. So we have our negative 3t to the fifth, and we add our plus 15t cubed. And then these guys end up, those cancel out, and we get 14t cubed. But this is where things will get interesting, because now when we bring down the 2t squared, right, so plus 2t squared, and we'll bring down 68t, because we know there's going to be a difference in 2 of the degrees, and if we have a cube, we're going to have a single t as well. So we're going to go ahead and add our 68t. And now let's figure out for term 2 of our quotient what we'll get. So we had 14t cubed, and we're going to divide it by our t squared, and we'll end up with 14t. So we'll add our 14t, and we end up with 14t times our t squared minus 5. Well, that's 14t to the third minus 70t. If we multiply by a negative so that we can add it instead, we get negative 14t cubed plus 70t. So negative 14t cubed and then plus 70t. And now those t cubes cancel out, and we're going to bring down our 2t squared and plus, well, that's 138t, and then we'll bring down the plus 10. And for our third part of our quotient, we'll now have 2t squared, right, divided by t squared. So we're left with 2. So we end up with 2 times t squared minus 5, which is going to get us 2t squared minus 10. Multiplied by our negative, it's negative 2t squared plus 10. So we add our 2 at the top, and let's see what we get. So negative 2t squared, well, those cancel like they should, and we knew there wouldn't be a t, but we add the 10. So even if we had hoped that they would cancel, they're not going to. We're left with 138t plus 20, and now this is our remainder, because the degree of the remainder is lower than the degree of our divisor. Our divisor is a square, our remainder has just a t. So we know we have to be done, and that's our remainder. So our function f of t, right, can now be rewritten as 3t cubed plus 14t plus 2, and then plus our 138t plus 20 over our t squared minus 5. And that is how we would write this quotient. The intention I had here was actually one that would have made this a little bit simpler. And I'm going to scroll just a little bit here. That would have been 3t to the fifth. It is still minus t to the third, but then it was minus 2t squared and minus 68t plus 10. And then we still divided it by t squared minus 5. So if you would like to try this one for additional practice, I believe we have enough space to do so. So let's try it. So we've got t squared minus 5. We're dividing it into 3t to the fifth minus t cubed minus 2t squared minus 68t and plus 10. And we'll see the difference that just changing the signs of some of our terms can make. And we don't often think that it's going to be a big difference, but it's surprising sometimes how different it really is. So we have 3t to the fifth over t squared. So still we end up with 3t cubed. We still have 3t cubed times t squared minus 5, which will still give us 3t to the fifth minus 15t. Multiply it by our negative, we'll get negative 3t to the fifth plus 15t. So this part should be similar. Oh, sorry, t cubed. Oops, there we go. Don't want to forget that. So 3t cubed. Okay, so negative 3t to the fifth plus our 15t cubed. So those cancel out just as before. We do have our 14t cubed, but now we're going to bring down our minus 2t squared and our minus 68t. And let's see how that changes things. So for term 2, now we have 14t cubed, and we divide it by our t squared, and we get our 14t. Okay, this feels familiar. Let's see here. 14t times t squared minus 5 is going to get us 14t cubed minus 70t. Multiply it by our negative 14t cubed plus 70t. And this is where things are going to be different because now we have our negative 14t cubed, no t squareds, right? And then we have plus 70t, but now that 68 was negative. And so now when we bring it down, the negative 2t squared just comes on down. Negative 68 plus 70 means we have plus 2t, and then we'll bring down our plus 10. And we can't forget to put our plus 14t at the top. And now let's see what happens when we try to finish this out. We now have negative 2t squared, and we're dividing it by t squared. So now we've got a minus 2 for our next term, which is a little different than what we had before. So now we have minus 2. Okay, so negative 2 times t squared minus 5 gets us negative 2t squared plus 10. When we multiply by a negative, we get 2t squared minus 10. And now when we bring this over here and add 2t squared and minus 10, the t squareds and the 10s both cancel out, and I'm just left with 2t as my remainder. So this one, we would say that f of t could be rewritten as 3t cubed plus 14t minus 2 and plus 2t over t squared minus 5, which was the much less complicated version of what I had intended for this problem. But we got a little extra practice, and that's never a bad thing. So now you've gotten a chance to try 3 quadratic divisions with polynomial long division. So when we get back to class on Wednesday, we'll take the time to answer any questions on this one, And then we'll just turn it in and we'll move on to partial fraction expansion questions, which you'll find in the next video.